Hi, I'm Anna Hoffman, and welcome to this special episode of Data Exposed Live. We have a very interesting episode planned for today to continue our security series. So without further ado, I'm going to go ahead and bring up our wonderful speakers that are going to be with us today. The first person I'm going to bring in is Mirek. Hi, Mirek. Thanks for joining us. Can you tell us a little bit about what you do?
Hello, Anna. My name is Mirek Sztajno. I'm a senior program manager in Azure SQL in security team. And I focus on authentication, primarily on the Azure Active Directory authentication. That is part of this presentation today. So welcome.
Awesome. We are happy to have you here, and it seems like you're going to be one of the right people for us to have on the show. Now, today we're also joined by Andreas. Andreas, thanks for joining us. Can you tell us a little bit about what you do?
Hey, sure. Thanks, Anna, for having me here. So just as Mirek, I'm a senior program manager in the Azure SQL security team. My area is access control, basically anything around permissions that you want to grant your users. That's where I'm working on.
Awesome, great. Well, it's going to be a great show today. We're excited to have both of you here. And today we're actually going to be continuing our Azure SQL security series. So for those of you who might have missed it, we will put a link in the description to the whole security series. This is actually the second episode in that series. Now, Andreas, can you tell us, and can you tell viewers who might not have seen the first episode, can you tell us kind of what this series is about, what we covered last week, and what we're going to cover this week?
Sure, love to. All right, so if you have joined last week, you may have already seen this little overview. So basically, we try to guide our customers in this vast topic of security to consider five fundamental pillars. One of them being Authentication and Access Management. We're going to talk about this area today. Another one being the data protection. Things like encryption would fall under that. Network security, I guess you have an understanding what this means. And data governance is looking a little bit from higher up, what data you have and how to protect that. And eventually also threat prevention and detection. So those are the fundamental security pillars that we are looking at. And piece by piece, we will look under the hood of those. So today we're going to talk about authentication and access management. And I will hand over to Mirek to cover the first part.
Awesome. Thanks, Andreas. I'm looking forward to learning more about this. I know a little bit about it, but I'm looking forward to learning more. So on Mirek, would love to hear from you more about authentication.
Okay, well, hello everybody again and welcome. I like to start where the previous episode stopped. That was emphasizing the Azure Active Directory authentication, giving the benefits in terms of the single sign-on, using the multi-factor authentication, the MFA, the conditional access. So let's briefly talk about Azure Active Directory that we also call Azure AD or sometimes AAD. That represents the central identity repository for Azure Cloud, allowing to store the identities and allow to manage identities. And it has plenty of users, customers who use it, and groups. One of them is the IT administration, who can provision users, groups, imposing MFA. There's another big group of users, application developers, who can use their single sign-on to develop their applications in Azure. There are the big variety of the Azure services that are offered with Azure Cloud, such as Azure SQL is one of them. We have others related kind of to the database like Cosmos DB or Azure Storage. And last but not least, there are these big products that Microsoft is releasing or did release, like Microsoft 365 or Office 365. That are the customers of Azure Active Directory. They store in Azure AD the identities. From the SQL standpoint, we support the following SKUs. these are the Azure SKUs. We start with the SQL DB. This is the oldest version where Azure AD is working, following by the hyperscale, following with the managed identity, and it is also supported for Synapse Analytics. So all these SKUs are supporting today Azure Active Directory, and we encourage customers to use them. From the authentication methods that we support for SQL Azure, there are several of them. And the main is the user password, where you provide the user credential and password. For the applications, this password must be hard-coded. There's the integrated or single sign-on authentication that is possible when we provide the federation between Active Directory and Azure Active Directory using Windows authentication. There's another method called universal or interactive with multi-factor authentication. And this method differs from the first one, from user password. Regarding the password itself, first of all, it allows to impose the multi-factor, the second factor authentication itself. But the important thing is that the password here is provided dynamically, which is slightly different than in the user password where you have a hard-coded. Dynamically means that during the authentication part, you have to specify the password. There's a token authentication where, in case if you can obtain a token from Azure AD, you can pass this token to SQL, and the token will be authenticated this way. There's the existing from the beginning SQL authentication that is supported for SQL on-prem. It's also supported for Azure AD, but we encourage customers, really to use Azure authentication to authenticate with Azure SQL. From the object standpoint that we support for Azure SQL authentication, there are mostly the objects that are supported today with the Azure AD. The users, that can be the native users that can be created in the Azure Active Directory. The guest users, these are the users invited from other Active Directories, Azure ADs, or from outside, like Outlook.com, like Live.com, or even Gmail.com. We support also groups, and these are the native groups that can be created in the Azure Active Directory. These groups are either created there, or they can be inherited from Windows when we do the federation between Active Directory and Azure Active Directory. And there are the groups, and there are also the users that can be used from Active Directory with Windows support. There's another class called service principals that are also called the Azure applications that can authenticate using their application ID and using the secrets or certificates. The last one is very important. It's a Azure AD administrator that must be created for Azure SQL. So this is a requirement to enable the Azure AD authentication for SQL. We always have to have Azure AD administrator there.
Gotcha. This is really useful, Mirek. It seems like there are a lot of different ways to connect, or that are possible for you to set up for authenticating. But what is the current security policy on using, say, hard-coded passwords to authenticate to Azure SQL?
So it is allowable, but it is not a recommended solution because it's hard-coded. You have to store it either in the application or somewhere in the disk. On the disk. So the better method is really to use the universal interactive, always impose multi-factor authentication, but also other options like use the integrated single sign-on using Windows authentication, or token where we use secrets or certificates. With this, let me go to the diagram, communication diagram. And here I have two scenarios that I like to present. And this is a on this first scenario, which is related to user and password authentication. We have an application on the left side. We have a driver in the middle, which is a SQL driver with a MSR on the top, which is the library. This is the access library that allows to access Azure Active Directory. And then on the right side, we have cloud that has two components, Azure SQL Database and Azure Active Directory. So let me just go through this communication diagram. For those who are who have less interest in the details, please take a back seat. But for others, it may be an interesting scenario. So typically, we start with sending a connection string from application, and you can see the connection string contains a keyword authentication equal Active Directory password, and this contents is then sent to the SQL database. Since it cannot be authenticated there, it goes back with additional information, like, for example, tenant ID, and then MSR is accessing the Azure Active Directory with user password credentials. It is authenticated there, comes back with the JWT token. It is sent back to the Azure SQL database. There's the optional group expansion for users with there are members of more than 256 groups, and then it comes back to the driver and it's sent back to the application. So this is how the user password authentication works. In case we use the federated authentication, so Windows authentication, we have another component that you can see on the left side, which is the on-premise Active Directory. And you can see also that this string differs because that authentication right now is called Active Directory Integrated. Again, the first part is the same that the previous one. We connect to Azure SQL Database as a pre-login. We send back this information to the driver, contact the Azure Active Directory, and this time the user cannot be identified there or authenticate there because we don't have a password there. So it goes back, and the request goes now to the on-premise Active Directory, where we find the Windows information about this particular user. It comes back here, goes back again to Azure Active Directory, comes back, and the part goes as in previous one. We send all this information to SQL database. There's the optional group expansion, and finally, after we have the authentication in SQL database, it goes back to the driver and goes back to the client. With this, I like to show a quick demo on the multi-factor authentication for users that are outside of Azure Active Directory. So let me switch now to
wow, this is really cool, Mirek. I'm excited. I didn't know we were going to get to take a sneak peek at this, so I'm looking forward to seeing this demo in action.
Yes, so what we have here is I'm having I created a server here. I call episode 2. This server has one database, the test MFA. And important, as I mentioned in the past, we have we need to create the Active Directory administrator, which is this group, in this case B2B, with my credentials. So let's look at the Active Directory itself, at the Azure AD, and let's check the group. So I create here a user group called guest. This group has one member, and this is the Outlook.com member, Mirek s.pm. And finally, let's look at the conditional access. where you can allow the policy. So if I created this policy here, right now it's off, the guest MFA. Let's click on the policy and let's revisit what is there. There's a name of the policy. There's a specific users that we are including. In this case, for this policy, I'm including user guest. Next, we need to indicate who is the receiver for this policy. And in this case, this is the Azure SQL Database. And finally, we need to define what kind of control are we using. In this case, this is the multi-factor authentication. So let me enable this policy. And with this, let's go to SSMS. So this is my SSMS where I log in as an admin, and I'm in the test MFA database. I have to map the guest user from the Azure Active Directory to SQL. Please do not confuse this guest user with the SQL authentication guest user that you may create. This is really the Azure Active Directory mapping of the guest user in AAD. So let's create this. And you can see that the user was created from the external group. And now with this, what we can do is we can connect. Let's connect to the database. Let's use this user, my Mirek s.pm, and let's check that we are connecting to the right database. So with this, we connect here. I'm putting my password. And then it asks me for the authentication. And I type the number. So I receive it on my phone. And you can see that I was able to authenticate as Mirek s.pm at outlook.com. So with this, let's come back to the slides.
That was a pretty cool demo, Mirek.
Thank you. I really appreciate it. I think this is very useful, especially for small business that is not using federated authentications, that guys that are really using outlook.com or gmail.com, but have a weak password, which means that in this case, they can impose the multi-factor authentication on it. So that's a nice thing that the administrator, that Azure administrator can do, or in this case, the SQL administrator. I like to talk about the authentication configuration options that we have. And from the cloud standpoint, we have two of them. We have Azure AD cloud only. So this is the authentication that does not require on-premises, or it's not related to on-premises. And it's only the objects are only created in cloud. There's the second part that is called the hybrid identities. And this is where we use, using a special tool, Azure AD Connect, you can federate or you can synchronize your Active Directory with Azure Active Directory. And the first method is for the ADFS, for Active Directory Federated Services, that we can federate it, that we can use single sign-on. This option is mostly used for the enterprise customers. For many of you, you are familiar with this for SQL on-prem. You can use this, but there are two other much lighter options that do not require ADFS, and this is the Azure AD password hash and password through. As I said, you can use for both of them the Windows passwords, but in the first case, the password is stored as a hash password in Azure AD. In the second case, the password is still stored in the on-premises. From the Azure SQL authentication standpoint, we have two methods. There's the hybrid, where you can authenticate with SQL either using Azure AD authentication or SQL authentication. The second one is a new one that will be available in public in May for public preview, and this is called Azure AD only authentication. First of all, it's this particular authentication disables SQL authentication. So it disables the server admin, it disables the SQL logins, the user logins, and it is driven or is managed using RBAC roles. RBAC is the Azure role-based access control. So you cannot control it from SQL. You have to do it from the RBAC, and Andreas will talk more about it in this presentation.
Awesome, thanks, Mirek. I've learned a lot about how we can authenticate, the different ways we can authenticate, the different considerations for authentication, as well as some of the recommendations that you have had given to us, as well as some of these like hybrid or cloud situations that are probably very relevant to many users that are in that hybrid or transitioning state. So thanks so much, Mirek. I'm going to bring up Andreas here as well. And Andreas, I'm interested to get your take, because we've talked a lot about how you authenticate to these databases, but there's also this idea of access, and Mirek kind of alluded to this in that how do I access the database from different places, and what do I have access to even see? So like the Azure portal, SQL tools, so Azure Data Studio, SSMS. So I'd love to get your take, dive a little deeper on how access works and what organizations need to know. Like, do you need to be a subscription owner? So lots of questions. Looking forward to learning from you, Andreas. Oh, you're on mute.
Yeah, of course. Thanks for the great handover, Anna. And yeah, absolutely point on. So what Mirek showed was who can access the system. As you want to know basically now, what can you actually do, right? And in SQL, we differentiate, or in Azure SQL, we differentiate between the ability to deploy services, not just SQL, right? There's other services in the Azure cloud. They have they are controlled with the same system, Azure RBAC, role-based access control. So you use that to actually deploy SQL database the first time, right? When you install the service, you can also configure it with that. You would automate the whole deployment processes and things like that. So use ARM templates to roll out your services for automation. And for doing all that, you would use this RBAC concept. Whereas once we have a database and you want to use your classic T-SQL tools like SSMS, Azure Data Studio, etc., then you would use a different permission system inside the engine itself. All right, and I'm going to speak about that in the topic after this one. So the first one being RBAC. Let's have a look at that one. So if you look at your subscription, as you rightfully mentioned, right, a subscription owner certainly can do all of those things, right? He has a superpower. That's the first level, right? You would have your Azure AD configured. Mirek prepared users there, for example. That's what you could see, and apply different policies, which would apply to certain resources like a SQL database, right? And you would organize them into resource groups. You can mix services under a resource group. In this slide, I just have have individual resource groups, one for SQL in the VM and the other one for a managed instance in SQL database together. It's really up to you how you organize that. You might want to have one for different teams, projects, etc. The idea is basically you apply then those RBAC roles, which then contain permissions, on those levels in the hierarchies to allow you to operate on those levels. So for example, I could make you a person who can deploy new resources, new managed instances or SQL databases in the first resource group, but not in that other one where you only want to have VMs with maybe different overall access, things like that. So in Azure RBAC, we support a very fine-grained access control. You can create your own definitions to support all these different roles that you will have. For example, somebody deploying versus somebody just looking what is there and how is it configured. Does it comply with my organization's security posture, with the requirements that I have to fulfill? Like, do I have MFA enabled here and there? Things like that, right? So you can apply all these roles and all these levels that you have. You can also make it very rough and just say in the whole subscriptions everything is equal. If this is a small subscription, may work, but you can have different levels of hierarchies there. So this is the first magic, or that you should absolutely use for Azure RBAC. Use the hierarchy levels. Now, let's have a short look inside such a role. What do I mean by granularity? So we have built-in roles in Azure RBAC, for example, owner, contributor, but also for SQL-specific roles like a SQL security manager, who has permissions to configure security settings in SQL Database and manage instance. All right, and if you were to look in the definition of that role, I have a small excerpt here on the slide. You see permissions that are actually individual activities, actions, they are called. For example, you can set firewall rules, auditing settings, vulnerability assessment settings, etc. There's much more. Right? There's just really a small excerpt. And based on that, you could also create your own custom roles for just some partial of these actions that we are giving you basically with RBAC. All right, and once you have these roles, you would then assign them to one of your AAD groups or users. All right, obviously groups make it much more manageable. Somewhere in the resource group on some resource using the IAM blade. We see in the screenshot here the IAM blade on the SQL database, where I assign myself as an owner on this level on the hierarchy, quite deep, right, on an individual database as an owner. But again, this is really up to you.
Gotcha. Cool. Thanks, Andreas. This is really interesting. It seems like RBAC is really powerful, and you kind of have this way to manage, and we even have these built-in roles you can use. I think you mentioned there's a lot more of them, but I'm sure we have customers, or is there scenarios where you might have like thousands of databases, and maybe even these databases are being dropped and created on a regular basis. Like, how can you? Is there a way to make that a little bit easier to manage?
Sure. So the idea is really to make sure that you use these hierarchies that we provide in the Azure system, basically in the ARM model, where you can have your resource groups with specific sets of services that belong maybe to a certain functional role or application that uses, let's say, a database, Azure Functions, and some other services or Synapse, right? And to use those. And once you have them applied at the resource group level, they apply to anything below that, even if there's nothing as of right now. So if you deploy something freshly under that, those will then be inherited in this structure. All right.
Cool.
All right. So this was the management deployment of services on that layer. What you can see in the portal, basically, to keep it simple. Obviously, also you can do anything with PowerShell, CLI, ARM scripts, ARM templates to deploy those things. All right. Now, as I said in the beginning, right, inside the database, once you have the database deployed by your RBAC permissions, you can then connect with your traditional SQL tools. And this is where now the next level SQL roles and permissions come into play. So the whole idea here is similar as an RBAC, that we want to enable you to enforce the principle of least privilege. So basically, to enable you to apply as little as possible permissions, really just what you really need to fulfill your tasks for the user. All right. So only that to support the job function. Also the idea, or why would you bother, right? In case there is a compromise, right, this limits substantially the blast radius, as we call it, in case of an attack, right? If an attacker takes over an account and that has been properly locked down with only the really minimal permissions, then he probably can't do much more, or not as much as he may wish to be, right? So on the contrary, for example, if you had always like very extended permissions on DBO level or SA level, sysadmin level, then obviously every compromise would immediately put you in high danger, versus when you really apply this principle of least privilege, then you can assure that the blast radius, it may be only at certain tables involved that can be manipulated, but not the whole system. All right, so this is one piece that's really important. And we provide you with a very vast permission system in Azure SQL. And currently, that's about 254 permissions that we support in SQL Database. It depends a bit on the actual SKU that you're using. I'd mentioned instance has a few less actually. So it has technical reasons, what functionalities are available, and they are all covered by permissions. Now, The key here again is you want to be efficient, so you want to use roles. This is similar to the idea in RBAC, in Azure Portal, right? You use groups in Azure in AAD. You can use RBAC roles to combine permissions. So in SQL, we use the term roles as well, built-in ones, and you can create custom ones to support your individual needs, right? And the third pillar that is usually very recommended to use when it comes to working with database objects, tables, views, procedures, is to really use the concept of schemas that we have. So group your objects inside your database within schemas, and this then altogether makes security manageable. All right, so let's have a little bit deeper look here. If you want an example of the permissions, this is actually just a small Excel, right? It's not 254 that I squeezed onto here. So you can download a big poster online. Just to give you an idea of the hierarchical system that we have in SQL Database and how that all works. What's the power of that? So looking at the slide, we see from left to right a database. Everything is inside the database here right now. On the left part, we see the highest level permissions. So you can grant the permission select on the whole database. That would be one simple way. When you do that, that means you have granted that select permission on every sub-object that's in every level of the hierarchy deeper. So the next level of the hierarchy is the schema that I mentioned before. And the last level of that of the hierarchy is the object itself, be it a table or a view. So the select permission would apply to basically all the tables in the whole database and all the schemas, right? When you do it like that. So as an example, we have this built-in role DB data writer that grants you really insert, update, delete. Those are the three operations that will change data inside the database, inside tables, right? On the whole database, right? Obviously inherited down to every individual table, right? As you can, by the way, see, it's not like that every level always has the same permissions. So for example, the show permission only exists on the whole database versus the view change tracking permission doesn't exist on a database. It only comes into play once you're at the schema level. All right, but again, this is just a small excerpt to give you an idea of the typical permissions to use. Now, as I said, maybe this is not exactly what you want. It's a big database, hundreds of tables. Maybe you don't want them to write to all of those tables or read them. So here you would use then custom roles, where you would basically define a role name and assign individual permissions on any level of this hierarchy, wherever you want it, right? But again, to keep it simple, I advise strongly against assigning it to object level permissions. It's very hard to report on that. Ideally, manage your, or ideally organize your object on a schema level, so you can simply assign the permission on a few schemas only. So the less permission statements, the less grant statements you have, the cleaner it is and the more easy to report on.
So Andreas, this is really interesting. It seems like, you know, like you said, this is just kind of a glimpse at some of it. I did put a URL up on the page if people want to go download this post. It's an actual poster, I think.
It is a big one, yeah.
Very big.
If you have a plotter, that's the one use case for that one.
But I have to ask, like, is there any difference when we think about this when we're setting it up for Azure SQL Database versus Azure SQL Managed Instance?
There is indeed. So one piece is actually also hidden on this slide already. On the left-hand side, we see a server admin and an AAD admin. This is one of the objects where actually this exists in both of these worlds, but it has a little bit different meaning, right? In SQL Database, you're usually oriented on a database level. You have users that are database users based on AAD accounts. The server admin always has every access, right? That's what I want to point out in this slide here. But the real key difference then is, and by the way, here's a little hint, if this is not granular enough, right? I know it's a big slide. Have a look at module signing. You can solve about any problem, any challenge with module signing. Anyhow, not to derive from that one, it's from the original question. So the difference between Managed Instance and SQL Database is kind of hidden on this slide, right? The SQL Database approach would usually be you have an AAD account, Shakti here in this case, being assigned to a database user or mapped to a database user, Shakti. ideally assigned then to a database role, and the permissions are applied to that role, right? Whereas this in managed instance, you start at the instance at the server level, right? Where you have your login. There's a small typo, as you see. Login Alice should of course match to a database user Shakti, or the database user Shakti should be on a login Shakti. Slight mismatch here. Although actually in theory it's supported by commands, you can do that, but it's not really a clean way. Anyhow, so you see this extra layer, right? Because these logins you can refer to from every database, versus AAD-based users, like Mirek showed in his part of the demo, they are database centric, right? And yeah, we're looking into extending that, but I can't quite give you a timeline where we will align these models. Right? So this is the main difference today.
Okay, cool. That makes sense. Yeah. So in Azure SQL Database, we have contained database users for all Azure AD accounts. Makes sense.
Yep. Yeah. And yeah, I try to bring up sometimes these acronyms here, ERP versus LERP. I know it sounds funny, but maybe that makes it easy to remember. But the concept idea is really user role, and permissions assigned to the role. That's the R in the LERP or ERP. If you keep this in mind, then you're on the right path.
Nice. I like it.
Yeah, it's kind of compared to the AGDLP acronym that Windows users sometimes remember when they come from security trainings in Windows. Anyhow, all right, let's see that in action. Small example here with me. So I prepared obviously a database already called Word Importers. You may have seen that in other demos. So more or less starting from scratch. I have an account. This is myself right now. So I'm just showing some examples here how you can have a look at your system. Right. So this is me right now. I'm a DBO. DBO means I'm a database owner. I have all power inside this very database, which happens to be Word Importer. So I'm connected to that one. You can also see it here in the bottom. There's a way to also find out, am I maybe member of any other groups or anything like that, or roles in SQL? No, I am not here. I am DBO. That's sufficient. You can't be more than DBO. And by the way, a DBO can't even be denied anything. This is a basic concept. All right, so there's absolutely no need of anything else. All right, I will always have all power within the database because I'm DBO. All right, I can have a look at which permissions are assigned to me by FNMI permissions on the database level. You would see we have 84 permissions that are database scoped. Doesn't mean that's all permissions that exist, right? There are other objects in the database that have other permissions. This is just an example of the database level permissions back from that slide that I showed. Not all of them are per schema or per object, and vice versa. All right, we can also have a look on which other principals, we call them, exist in this database. So which other users or roles, all of those are principals, users and roles. You see a couple of accounts here being set up. We see a difference. Most of them are SQL users, and one of them is an external user based on an AAD account. And some other information like when they were created. Obviously, we also have a view to detect are there any memberships and any roles. And if you combine all of that, you can see who has which permissions via which roles. All right, so we see it's pretty clean here. And this model is not too much customization. The guest has a special permission and the trainee account has the unmasked permission. Other than that, nothing out of the usual yet. Pretty basic setup here. So now I want to enable new users to work with this database. Ideally, again, I would create a role for each of my scenarios. So I want to show two scenarios, one for developers and one for just some random application purchasing team that needs to read some tables. All right, so I create a role and that's all I need to do, right? It's just a name at this point. I will have two users, which I will then assign to those roles. So dev Shakti, password, and a SQL user purchasing Jiao, just to make sure that we understand which role they will be member of. Obviously, this is a SQL account, not an AAD account. So this is why they have a password here. And then I assign them to those prepared roles, right? Role devs gets the member dev Shakti, and purchasing is Jiao. So pretty clean one-to-one relationship between roles and users at this point. And I'm going to give some permissions. So my devs, I do it the simple way. We have this built-in role, DDL admin, that will be assigned to or the other way around. The role devs will be made a member of the role DDL admin. So as you can also see, I can nest roles. I can make one role member of another role. You should definitely not overdo that, but in this case, like you have a built-in role that actually matches your scenario, that is a valid scenario. But I wouldn't do it like multiple layers, even though it's supported. And the other role, the purchasing team, I will basically grant a permission, select, and execute 2 permissions on a whole schema. This is this next level of objects that we have inside a database. So schema has a name, purchasing. So if you have ever seen our example databases, you will have seen that these tables have prefixes. It's expanding a bit, and then you will see the table names. And they usually have some intelligent names like this, application dot, and then it comes the table name. So the first piece of the name here is really the schema name. It's not the table name. You also see if I press F2 to change the table name, you would suddenly see, no, purchasing is not part of the table name. It's purchase orders, which happens to be in the purchasing schema. All right, so this is where you can notice this in the UI. So I'm basically granting the select permission and execute permission on any object that is in the purchasing schema to that role purchasing. So this is a very simple way. I basically just assigned 2 permissions in one statement on multiple objects, any table, in now and also in the future if anybody creates new tables. All right, so let's test that. There's an interesting method you can use is execute as user inside your database. So you just, me as a DBO, I obviously have this power. Not everybody can do that, but a DBO can always impersonate any other database user. So I'm gonna switch my current context now. I can prove you I am now really Dev Shakti. This is who I am right now. And if I look at the user token, I will see a big difference to what I saw above under my own token. Now I'm a SQL user, Dev Shakti, no surprise here. Member of public, okay, not too interesting. The public usually doesn't have any permissions. I'm also a member of the role devs, and I'm also a member of DDL admin. So it's basically all combined now because role devs is member of DDL admin and Shakti is member of role devs. All these roles are basically part of my security token now, and I inherit all their permissions. So which permissions on the database? We remember this function. You will see we have 48 permissions, right? So remember up there, DBO had 84. Well, we don't need to remember all the details, but obviously the DDL admin role has a big chunk of those database level permissions. All right, so this is one way to tell. Okay, so what can you actually see, like objects that exist, all right? Select star from systables, so you can really see every table in obviously any schema. Of course, there are different schemas there, 48 tables. What else can you do? Remember, is a developer role. So one thing they cannot do is select from those tables. This is really just to support DDL commands. They can change tables definitions, but they can't look inside the tables. So this is maybe exactly what you want, right? So what else can you do? He can create a new schema, right? That's part of the developer's work. He creates a schema and creates a table inside that schema. That would be the syntax for that. Create schema, create table in that schema with some columns. And in that table, he has actually now full power. He can also read on that. And before you're wondering, and the reason is simply, it is his table. He is the owner of that table. He created that himself right now, part of his development process, right? So he does have full permissions. There is nothing, he's not exposing new data. He just put it there himself, right? But it's something to be aware of how this whole system works, right? He can obviously drop his own tables in any other table as well. And he can create procedures, like I'm going to create a procedure per set purchasing, select purchase orders non-finalized with some where clause. Now we're going to use this one later on. By the way, he does not have the execute permission for his own procedure. Interesting, right? So this can make testing a bit tough, but you could assign the execute permission. And then obviously also you would see the data. So he just created she just created a procedure here. All right, let's get out of here. Let's remember the name procedure is purchasing. That's part of the schema. If you remember purchasing team, member purchasing Joe, she has permission execute and select on that schema. So let's see what happens. Let's just check. Yes, we are really Joe. Her permissions on the database, not so much. All right. But she has permission on the purchasing schema, select and execute. That's what we granted her via the role. And what can she see? She can see a few tables, those tables who happen to be in the purchasing schema. You can see it also on the left side here. And can she select any other tables? No, definitely not, right? Because we didn't grant that, but she can select now from the purchasing tables. So that all works. What about this newly created procedure? Remember, I granted the execute permission way up in the script, and Shakti just created the procedure. Let's see. It works. That's fancy, right? So the procedure was created after the permission on the schema was assigned. So this is how it works, right? Jiao doesn't have the permission to execute this individual procedure. She has the permission on any procedure inside the purchasing schema. So yes, it applies to any future object as well. Now the second clue here is, why can't she see the data even though she may not have select permission on the actual table, all right? This is another thing that I will show in a later slide due to ownership chaining. All right, let's log out, back who I am, and so on. Okay, this was a small example on SQL permissions. I hope this explains a little bit how you can go about it.
Yeah, that was actually really cool, Andreas. We might have to add another URL to our description to give people access to kind of play with this, because I think it's a really interesting learning exercise to see how those different permissions that you're giving change what people can access. I really liked it. So thanks for sharing it with us.
Sure thing. So one of the concepts I mentioned in the end of the demo was ownership chain. This is something that people who are new to SQL sometimes get surprised by, and is important and a very efficient method that SQL has, actually specific to SQL, Azure SQL or SQL Server even. This is ownership chaining. So in SQL, you can have a following scenario. You may have a user or a role and a table or multiple tables inside a certain schema data. In my case, in the demo, the schema was called purchasing. This is the level that I'm talking about, a schema called data. There are tables inside. Maybe you don't want them to actually directly accessing those tables. Maybe you have columns that you don't want them to ever see, or maybe rows. You basically want to ensure they can see the data, but only after you have treated it with certain business logic via a view or procedure, all right? So let's say you don't grant select permission on that schema. Obviously, then they can't select from there. Now you do create views in a different schema. Let's call it access schema. Those views, they can be accessed by the users if you grant the select permission on the views, on the view schema. And the views will access the tables just fine. How would this be possible? This works if both of those schemas are owned by the same person. So the idea here is basically that as long as the object owners are the same between the views and the tables, this is the chain, same owner, app schema owner. If you then place the select permission on the higher level, in this case, the view, or the whole schema containing the view, you do not need to grant explicit select on the lower level permission objects, like the tables here, but they can use the views just fine and access the data. Obviously, views can contain business logic like filters or even conversions of data columns, calculations, etc. So this is a way to ensure they can't even see the raw data from the tables, but they can see the data as presented by the views. So this is, thanks to ownership chaining, a very interesting concept, very special to SQL Server also.
Cool. That's very interesting. I never really thought about how you might go about doing this, but it kind of makes sense. And SQL permissions are going to give it's going to cover a lot, right? Like if you have access to databases or tables, even procedures you showed us. Now, one question I have is, have you ever seen scenarios where customers need to use tables in such a way that like certain people only need to see certain rows or certain columns? I guess what I'm asking is there a way to do like vertical or horizontal splitting?
Yes, there is indeed, Anna. Thanks for asking. So now you're getting really into the nitty-gritty details here, right? Even a level deeper than that. There is a technology that we have in Azure SQL, is called role-level security, which basically gives you this ability to filter out rows based on the current user who is accessing the very same table versus another user who will see then different rows. All right, so this is used in like multi-tenant scenarios where you have big tables shared by multiple, let's say, end customers. You have a shared schema, multiple end customers, end users using the same schema, database schema. This is where this becomes very handy. It can also be used even for the need-to-know principle, where you would basically, again, have a logic to say, well, you may have permission on that table. You have to select permission. You need that. But on top of that, you need to have a valid need-to-know to actually see that certain row, right? Maybe you can't see every patient or every product patent details, etc., based on your role function in this company, right? So those are the high-level examples where you would have this this very use case. So I will not show a T-SQL demo. I'm going to spare you this for now for this video, but just to give you an idea of what this works like. So we have here an example of a hospital. Right? There are nurses, for example. They are in a database schema. They have a representation with a employee ID, in this case 100986, and they use an application. All right, and there is a table inside my database called patients with data from all my patients. All right, so in this scenario, we don't want really every nurse to be able to see every patient's data, because there are many, many patients. The hospital is organized in different departments. Here, for simplicity, I just use a wing. So we have a way to organize our staff by wing that they are assigned to. So in this example, we can see the 100986 employee ID is assigned to wing A1 versus other employees being in other wings. So what we want to accomplish here is to make sure, yeah, the nurse can look at every patient's data as long as it's in the same wing of the hospital that she is working in, but she can't look across wings, right? So, and to accomplish that, we behind the scenes can implement a security policy. That's what it actually is called. It's a T-SQL object assigned to the table. And when now the application initiates the select from the table, like so, it will behind, using the security policy, filter out the rows that don't belong to the current user's employee ID. So there is a little bit of logic, and you're very flexible in terms of what exact logic you want to use to make sure that you only return the data that in this scenario makes sense. So this is one way of filtering. Yeah,
that's a cool example. I like that example because not only, I mean, I guess, of course, from a security perspective, you're only showing the data that, you know, a certain nurse should be able to see, but also from a business logic perspective, it's kind of making it easier because by limiting this person's access, they're only going to see what's actually relevant to their job. So that's kind of helpful too.
Exactly. Yeah, point on. So this is a great way to enhance the functionality of your application, the security of your application using T-SQL. You don't have to bring this logic inside your application. Yeah.
Cool.
All right. So this kind of sums up our today's topic. So remember, we first talked about access control, and Mirek showed us some great examples of how you can harden basically the authentication process with MFA. Remember, we really recommend you to use Azure AD authentication over SQL authentication. Albeit it's simpler sometimes, but simpler also makes it easier to circumvent. right? So we simply have more security around the AAD mechanisms. So that's one key takeaway here. And by the way, it also simply makes life way easier if you want to communicate with other Azure services. They don't speak T-SQL natively, so Azure AD is the authentication of choice there, really. The second part that we looked at is Azure RBAC. So there, remember, this is a technology. Use it wisely in your hierarchies. Assign roles in your hierarchies of the Azure subscription. And lastly, the SQL security permission system, very big, very huge, lots of fine knobs that you can use to really limit your users' access. Again, making sure that your users can do exactly what they need to do, but not so much more, to limit exposure in case. And we always assume breach, right? Remember, that always account for that. It could happen. So this is number one rule to keep in mind. Right.
Cool, awesome. Thanks so much, Andreas and Mirek. So now we've kind of talked about authentication and access management. So does that mean that next we talk about data protection? Is that the next topic in our series?
I suppose so. Anna, you will be the host again, I hope. Right. So yeah. So yeah, we talked today about authentication. That was the first bucket. Right? As you can see, we covered a lot there, and the next bucket pillars are going to be equally informative, I'm sure. All right. So lots of encryption things coming up in data protection and network security, and then the data governance. So it's really a lot of functionality that we can provide you, so you can ensure that your systems can be compliant according to your requirements.
Awesome. Well, thanks so much, Andreas. I'm also going to bring back Mirek up here. I want to remind people that if you want more of this or you want to follow along with this series, we are grouping all of the episodes in this series in a playlist, which you can see on the bottom there. So we'd love if you would join us and stick around. I think the next one will be in June. Andreas, if you don't mind, yep. So the next one will be in June. We'll be talking about data protection. So you can see we have a series planned throughout the whole year to help you and me and everyone else watching learn more about Azure SQL security. Oh, we got some nice comments. Kev Ball says, great info. Thanks, Andreas. We've seen some other comments come throughout. Thank you. So thanks all for tuning in. This was a great episode. Any final closing thoughts, Andreas or Mirek?
Well, thanks for giving us this opportunity to be exposed in your famous channel here, right? To talk about one of the most crucial things for, I think, all of our customers, right? Data security, protect your data, that's your assets. Absolutely want to make sure of that. So it's a huge field. We have obviously many pillars that we covered and will cover. So we are glad you took the time to talk with us, and our viewers are taking time to look at these details. I hope it was useful for everyone. Let us know if you have any feedback of any sort. Right? We are always listening, although we can't do everything at once, but we want to help you as our customers, quite obviously.
And from my side, thank you all for participating in this presentation. As you know, security is the key element in every development. We may have the best applications. If they are not secure, this is a big problem. So I hope that we enjoy this particular presentation and those that will be coming in the upcoming time that Maria will announce. Thank you so much.
Awesome. Thanks so much, folks. Thanks to our viewers. If you like this video, go ahead, give it a like, comment, and let us know what you thought. And we hope to see you next week on Data Exposed.